Hello everyone. First of all, let me apologize for the delay. There was some net problem, therefore I could not start at sharp 7 p.m. IST. Sorry, I'm late by 3 to 4 minutes. Let us start. Let us start the session. And today is the third session of this topic, the binomial theorem, a plus b whole raised to the power of n, where n is a positive integer. And we have learned that a plus b whole raised to the power of n is this. What all did we learn in the two sessions, in our past two sessions? We have first of all learned that what is a binomial? First of all, what do we mean by this term binomial? Whenever you have this word or this prefix bi, it means two. It can be a bicycle, it may be a binocular, it can be binary. So whenever you have the prefix bi, it means two. So binomial, obviously, it will be connected to something two. What two? It is an algebraic expression containing two terms. It can be algebraic expressions, it can be two numbers also, but we can obviously add the two numbers to get a single term. But for an algebraic expression, if the two terms are unlike terms, we cannot add them. We have to keep them as it is, as two terms, as a binomial. Okay? We can have, that is why I am saying that it is an algebraic expression containing two terms. It's not that you cannot have a numerical expression of two terms. Of course you can have. And if I say 2 plus 1 raised to the power of, say, 4. And this is the binomial expansion. We have seen how do we get to these things, these terms. We have seen these in our very first session and in our last session also, the second session that we have had. We have seen what are the coefficients, how do we get them in C1. These are NCRs, NC0, NC1, NC2 and all. How to get the values of these NCR terms, which are the binomial coefficients, using the TI-inspire, and how to evaluate them manually. We have seen both of them. And we have seen the powers of A, the first term of the binomial goes on decreasing. The first power is the same as n, and it goes on decreasing, and the power of the second term of the binomial expression goes on increasing in steps of 1. We have seen all these, and we have also learned, or we know actually, since if someone says that what is 2 plus 1 raised to the power of, say, 4, let me write it, 2 plus 1 raised to the power of 4. Should we be using the binomial theorem? Should we be using this expansion? Definitely not. If someone asks us to use this expansion, we will simply be ignoring that person. And we will be just adding 2 plus 1. We will be getting the summation as 3, and we will be raising that 3 to the power of 4 to get the answer as 81. Simple. So it is not, even though this is a binomial expression, we do not need this expansion in order to get to the answer. Right? But is it always true? What happens if we have, say, the number is 102 to the power of 3? Of course, you may say that, well, we have the calculator. If you have the calculator, you don't have to do all these expansions. Yeah, of course, if it contains two unlike terms, definitely you will be having the expansion. But even if you have two like terms, two algebraic like terms, you will be adding them and you really do not need the binomial expansion. So I'm not talking about having the calculator. For IBDP people, you all have a paper, that is paper 1, which is without calculator. So how to find this 102 raised to the power of 3? One way is, of course, 100. This is equal to 102 times 102 times 102. Of course, we can multiply this. But is it very easy to multiply this 102 times 102 times 102? What if we write this 102 in the form of 100 plus 2 raised to the power of 3? That means n value is equal to 3. So what will be the expansion of 100 plus 2 raised to the power of 3? We know the first term will be simply e to the power of n. E is 100 in our case. So it will be 100 to the power of 3 because n is equal to 3. Second term will be NC1, the coefficients. First term's coefficient is NC0, which is 1. Second term's coefficient is NC1, n is equal to 3. And 3C1, NC1 is always equal to n. We have learned this in our last session. So 3C1 should be equal to 3 times 100. The power of 100 will go on decreasing, so it will be 100 to the power of 2. And times the B value is 2 in this case. So it is 2 plus, let me shift it a bit. Next is NC, this was, first one was NC0, second one was NC1, third one is NC2, which is NCn minus 1, which is equal to n. We have seen NCn minus 1 is also equal to n. So this will again be equal to 3 times 100 to the power of 1, which I am not writing, times 2 to the power of 2 plus the last term NCn. Well, sorry, what is happening? Today is giving some problem. It's flickering and sorry. 2 to the power of 2 plus 2 to the power of, my goodness, just a moment. To the power of, it's continuing, 3. So this should be equal to 100 to the power of 3. So 1 followed by how many zeros? 6 zeros. 1, 2, 3, 4, 5, 6 plus. I am explaining, so I am doing these calculations slowly. But of course, you will not be doing as, and also I'm not being able to write, I don't know why, properly. So it is taking quite a lot of time. But it is definitely not the time that you will be requiring in order to calculate this part. You will be taking much less time. I know that. So 3 times 2 is 6 and 100 to the power of 2. So it will be followed by 4 zeros. Plus 2 squared is 4. So 2 squared, 4 times 3 is 12. followed by 2 zeros, plus it is to the power of 3 actually, plus 8. Okay, so this is the expansion, and so now we will be just adding there is only one non-zero term in the units place, that is 8. In the tens place, it is totally a 0. In the hundreds place, this is the only term that you are having. And then thousand, the fourth one. This one is 1 and you don't have any other term, non-zero term. So it is 1. And then the fifth one is 6. And then this is 1, 2, 3, 4, 5, 6 and 7. So it will be 1061208. This is the value of 102 to the power of 3. You may verify by multiplying them, or you may use a calculator to verify this answer. You will be seeing that you get the value as 1061208. Okay, so if it is a paper 1 question, and if they ask you this type of a question, it will be obviously a subpart of a question, just to check whether you get to the correct answer using the binomial theorem. It will not be this easy, but yes, it may be a paper 2 question, and then you may have a number, say it may be say 2.01. I'm not doing this, but if it is asked to get the value of 2.01 to the power of 4, and this will be a paper 2 question, definitely this can be a paper 2 question. So first thing that you will be writing is, you write 2.01 as 2 plus 0.01. So A will be equal to 2, B will be equal to 0.01, and N will be equal to 4. And you get the expansion. I'm not being able to write that side. Okay. So N is equal to 4, and you have this binomial expansion. So you can use this to get the answer of, or the value of 2.01 to the power of 4. And this can definitely be a paper 2 question from the binomial theorem chapter. Okay, so it is not that I have shown you something irrelevant. This is a relevant question. I have shown you an easy one which can be done without a calculator. This can be a paper 1 question, but if you need the calculator, like in this case, you will be needing a calculator perhaps. This will be a paper 2 question. Okay? And now I am saying so many things about binomial theorem, and I am saying that yes, you need the binomial theorem. So when you have two unlike terms. But you may ask me that why should I be needing this? Miss, why should I be, say, suppose I say you have 3x squared plus 2x cubed raised to the power of 5. So either you go on multiplying 3x squared plus 2x cubed times 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 3x squared plus 2x cubed. So you will be having the number 5 times and they will be getting multiplied together. That is the very primitive method. And other way is to apply the binomial theorem. But you may just see, you may just ask me that why do we have to expand this? Means, are you teaching us to multiply a same expression or a same number multiple number of times. Is that your target? No, definitely not. So this gives rise to this question: why do we need to learn the binomial theorem? Well, there are cases in higher mathematics or in higher physics problems you will be needing the binomial theorem, but I will not be definitely going into those parts in this session or in coming sessions. But the one that is included in your syllabus is the questions on probability and statistics. You will be using this binomial theorem when you will be solving questions from the part probability and statistics, which is included in your syllabus. Over there, you will be using the binomial theorem. Okay? This is for the IB students mainly. Okay? So, therefore, this binomial theorem is not an irrelevant topic that you can, of course, you cannot avoid it. It is in your syllabus. You will be getting questions on this, but it has some relevance. It is not only that because it is in the syllabus, you have to learn it. It has some relevance. It has some applications as well. Okay? So, and also for these, you have seen that if you, especially in this case, if you are not having a calculator, in case you have forgotten to take a calculator somewhere and you need to find the cube of some number, then you can use the binomial theorem. These are just arguments I'm giving just to make you realize that this is not an irrelevant topic. Okay? So now we know that this is the expansion we have learned. Oh, sorry. Oh, I didn't remember that I have taken up this question. So, okay, since I have taken up this question, let us do this. Okay. Answer. 2 plus x. Find the binomial expansion of 2 plus x to the power of 4. And let us start. 2 plus x to the power of 4. Equal to the first term will be a to the power of n. N is equal to 4 that we have seen. So it will be 2 to the power of 4 plus x. It is not, I have taken 2.01. This is the subpart, the second part of this question. So first of all, let us expand this. Next, it will be 4c1, which will be equal to 4. So 4, and it will be 2 to the power of 3 times x plus, it will be 4c2, which is 4 factorial. Now, if you are not understanding this part, that how is it 4c1, how is it 4c2, and I'm writing the expansion of or the formula of 4c2. If you don't understand this part, I would definitely be asking you to watch my previous video. In my first video, I had shown you how to get the value of NCR using the TI Inspire calculator. And in my last video, that is the second session, I have shown you how to get these values manually. Okay, so if you do not know how to get the values manually, I would definitely be asking you to watch my second session, that is the last session. Okay, so this is 4c2 and it will be 2 to the power of 2 times x to the power of 2 plus 4c3, it is nc1, sorry, ncn minus 1 it has to be 4. So I'm writing 4 times 2 times x to the power of 3 plus the last term coefficient has to be 1. So it will be x to the power of 4. Clear? Okay. So this is equal to 2 to the power of 4 is 16. 2 to the power of 8, 2 to the power of 3 is 8. 8 times 4 is 32. X plus. Now 4 minus 2 factorial. Let me do this over here. Okay. I'm just boxing this part, making a rectangular box. Yeah, and I'm doing the calculation over here. 4 factorial can be written as 4 times 3 times 2 factorial, and it is 2 factorial times 2 factorial. These two can get cancelled, and 2 factorial is what? 2 times 1. 2 times 1 is 2. So this is equal to 2, and 2 times 3 is equal to 6. Okay? And 2 squared is equal to 4. So 6 times 4 is 24. 24x squared plus 4 times 2 is 8, 8x cubed plus x to the power of 4. Okay. So this is the expansion. This is the first part. And this subpart, we have done the first subpart. Now coming to the second subpart. Hence find the exact value. Now this is important. Exact value. We cannot give any approximation. 2.01 to the power of 4. Now in this case, x will be 2 is 2, but x will be equal to 0.01. Okay. So wherever we are having x, we will be substituting this 0.01. Okay. And yeah. So let us do that. 2.01 to the power of 4 can be written as 2 plus 0.01 to the power of 4, which is equal to 2 to the power of 4. These are the same, so I write 16 plus 32 times 0.01 plus 24 times 0.01 whole square plus 8 times 0.01 whole to the power of 3 plus 0.01 whole to the power of 4. Okay. So now we have to just do the calculation, the simplification and all those stuff. So 16 plus, let me express these in fraction forms. So this will be 32 over 1 over 32 times 1 over 100 plus 24 times, this is 1 over 100 whole square. So it will be 1 over 1 followed by 4 zeros plus 8 times 0.01 to the power of 3. 1 followed by 6 zeros 1, 2, 3, 4, 5, 6. And finally 1 followed by 8 zeros in the denominator. 1, 2, 3, 4, 5, 6, 7 and 8. Most probably, why am I having a problem? Most probably because I'm appearing over there, that's why. Maybe that may be one of the reasons. I don't know whether that can be a reason, but suddenly I realized that I am appearing in that area. Okay. So this is 16 plus, there are 2 zeros, so it will be 0.32 plus, there are 4 zeros, so it will be 0.0024 plus 6 zeros, so it will be 0.1234, then 8, and finally 8 zeros, so 0.123456 7 and then 1. Okay, so what is the sum total? 16 plus, now we are sorry, not plus, 16 point, I'm not being able to go to that side. 16.32 and then 24 and then let me write this 2 properly, 3224, and then we are done with 4 places, 1, 2, 3, 4, and then we have 0, 8, and then we have completed 1, 2, 3, 4, 5, 6, and these two are 7 and 8, so 0 and 1. Okay, so this should be the answer. Well, I did not open the TI Inspire. I have forgotten, and I am not sure whether I'll be needing it in this session. So let me just use a normal calculator. Okay, I'm using this, and let me see that what value do we get for 2.01 raised to the power of 4. 16.322408001. Perfect. Okay. So this is how you can get the answer using the binomial theorem. Clear? Now coming to another part of the binomial theorem. So this one is, okay, let me bring it over here. We know this part. Now, instead of writing, how many terms did I write? 1, 2, 3, 4, and 5. And in between, I have put these 3 dots, indicating that there are so many other terms in between. So, instead of writing such a long expression, the same thing, mind you, the same thing can be written using this sigma notation. Actually, this should be written in this form. In the typing way, I got them in this form. I could not get them in this way. R equal to 0 should be below, and R equal to n or simply n should be above the sigma notation. It is this one. Okay, this is known as the sigma, which means summation. Yeah, it is like a zigzag form. It is a Greek letter, so it is known as sigma. SIGMA. At and it stands for summation because all the terms are getting added. There is the addition sign in between the terms. All the terms are getting added. So sigma stands for summation. Whenever you have number of terms getting added and you want to write it in a concise manner, then you may use this sigma notation. We use the sigma notation just to save space, save time, save energy. Okay, you can write the same thing in an expanded form. The first line is the expanded form. The second line is the concise form, shortened form. Instead of writing so many terms, I have just written only a single term with R variable and with the prefix of that sigma part. Okay, so this is writing the binomial expansion using the sigma notation. How do we write that? See, over here we are introducing a variable R whose starting value, whatever we write R equal to, that is the starting value of R. Okay, and the ending value of R is the upper number. And the R value will be, it's not that you have to take R every time. You can take any other letter as the variable. Okay, but the starting value should be 0 and the ending value should be n, whatever is the value of n. That is the power. So, and this shows that we have seen that how many terms will be there in the binomial expansion. There will be n plus 1 number of terms. Obviously, this also proves that because the starting value of R is 0, the ending value of R is equal to n. So from 0 to n, there should be n plus 1 number of terms. Okay. So, an R value will be going on increasing in steps of 1. For every term, you will be having a different R value. The n value, the power remains the same, obviously, but the R value changes from term to term. For each term, you will be having a different R value. The starting term's R value is 0. The ending term's R value is equal to n. And for in between terms, the R value just goes on increasing in steps of 1. Okay. So we will, if we just substitute, forget about this part. Starting terms R value is equal to 0. And you see, instead of NCR, we have written NC0. So we have just substituted the value of R over here. A to the power of n minus R. So this should be a to the power of n minus 0 or a to the power of n. B to the power of R or b to the power of 0. Clear? Second term's R value is 1. 0 plus 1 is 1. So it is NC1. A to the power of n minus R or a to the power of n minus 1. B to the power of R, which is b to the power of 1. Third term, R value will be equal to 2. So it is NCR becomes NC2. And a to the power of n minus R becomes a to the power of n minus 2. B to the power of R, since R is equal to 2, it is equal to, it is equal to 2. Most probably, actually, I have copy pasted this, so very sorry. Most probably this also has the same mistake, right? Over here, it should be 2. And this way it continues, and for the last term, the R value is equal to n, therefore it is NCN, e to the power of n minus n, which is a to the power of 0, and b to the power of n. So we have written the same thing but in such a short space, small space, using the sigma notation, because sigma means summation. We will be writing every term. This includes every term of the expansion, and how to get each term, we will be replacing the R value and we will be getting a particular term. And all the terms will be added because of the sigma. That is what sigma is representing or signifying. Okay. Now comes the general term. This is very important, the general term expression. See the difference between the binomial expansion and the general term expression. The part that is missing in the general term is sigma, because it has to be, because for a general term, the R value will be a constant. For the first term, R value is 0. It will not be changing. For the second term, the R value will be 1. And you will not be having multiple terms added together. So there is no need of this sigma part. So this is the whole expansion and this is the general term formula. It is having exactly this part from the whole expansion. Only part that is missing is the sigma part. And it obviously makes sense because a general term will not be having a sigma, because sigma is summation of multiple terms. And this is a single term. A general term is a single term from the expansion. Okay. Why is this important? Because let us come to this question. We had taken up a similar question as the last question of our last session. Now let us solve this question. Let us get to the answer of this question using the general term. Okay. Now this is the question. What is the coefficient of the fifth term in the expansion of 1 over x plus x raised to the power of 10? So A is equal to 1 over x. B is equal to x. And n is equal to 10. Okay. Now we have to get the fifth term. So this is the general term. We will be just putting the values and we will be getting a particular term. So in this expression, what is unknown? We know n, we know a, we know b. What is unknown is the value of r. What will be the value of r? Whenever you will be having this type of a question, find the coefficient or find the term. Only thing that you have to find out is the corresponding R value, which will be unknown. Because N will be known, A value will be known, B value will be known. The only part which will be unknown is the R value, which has to be found out. Since they have said that it is the fifth term, the first term's R value, R starting value is 0. You have to remember this. Always the starting value of R is equal to 0, not equal to 1. This is a very common silly mistake. Fifth term, they will be taking the R value as 5. No, because the R starting value is equal to 0. So for the fifth term, the R's value, corresponding R value will be 4 and not equal to 5. This is a very common silly mistake. Okay? You have to remember this. Because R's value starts from 0, for the fifth term, for any term, you have to just subtract 1 from it, from any term number to get the value of R. So in this case, the R value for the fifth term will be equal to 4. Clear? Now we will be just substituting the values in this expression and we will be getting the fifth term. Okay, so n is equal to 10. Okay, I need a calculator. Sorry. Let me just try to open it. It will be taking some time. So it is 10CR, 10C4. E is 1 over x to the power of n minus r. So it is 10 minus 4. And of course, they are connected by this implied multiplication sign. And b is equal to x. So x to the power of r or x to the power of 4. Okay. Where did it go? Oh, it is coming. Okay. So this is equal to, let me just write the expression at least for 10C4. It will be 10 factorial over 4 factorial times 10 minus 4 factorial. And this is 1 over x to the power of 10 minus 4 is equal to 6. Thank you, it has come. Okay. So it will be 1 over x to the power of 6. And this is x to the power of 4. Yeah. So let us try to do it manually as much as possible. So I can just get the value of this part 10C4 over here. Again, I make a rectangular box. It is this 10 minus 4 is 6 factorial. So I can write this as 10 times 9 times 8 times 7 times 6 factorial over 4 factorial is 4 times 3 times 2 times 1. I am not writing 1. Or okay, fine. I write the 1. And 10 minus 4 factorial is 6 factorial. So these two will be getting cancelled and I can cancel these two. Okay. And this one is 3. Fine. So 3 times 7 is equal to 21 and 21 times 10 is equal to 210. I did not need a calculator for this. Okay. So it is 10C4. Yeah, of course, if you want, I can verify. That can be done. So menu, it is add calculator first of all. Fine. And add menu, and it is probability and then combinations. And NCR is it equal to 10. I have to write 10 and then comma and then 4. The parenthesis and this. See, 210. Okay. So we can evaluate NCRs without the help of a calculator. Right? So no one should consider us to be worthless creatures. Okay. We are being able to get the NCR values. Of course, you may say that is the word depending on whether you can get the value or you cannot get the value of NCR. No, not that way. Okay, I'm just joking. So 210 times, that is x to the power of 4 is in the numerator, x to the power of 6 is in the denominator. So it will be x to the power of 2. Okay. So whenever they say find the coefficient, what is the coefficient? It is usually the numerical coefficient. They imply the numerical coefficient. Coefficient of what? That is not written over here. It is the coefficient of x to the power of -2. Because this can be written as 210 times x to the power of -2. So what is the coefficient of the fifth term? The question could have been in this way. What is the coefficient of x to the power of -2? Okay. So when they ask for the coefficient, don't give the x part. If they ask for the fifth term, what is the fifth term? Then you give the entire thing. Either in this form, 210 over x squared, or 210 times x to the power of -2. Yeah. So you can give any of these if they ask for the fifth term. But if they ask for the coefficient, so you write only the number. Coefficient, therefore, coefficient, I am writing only the coefficient because I cannot go to that side. Coefficient of the fifth term I'm really scared of going to that side today. Fifth term is equal to 210. Okay. So this is our answer. Coefficient of the fifth term is equal to 210. Coming to the next question. Oh, it is also having the power of 10. Okay. Now, the question is, see, what is the coefficient of the second last term in the expansion? Second last term, they did not mention what is the term number. So can we find the coefficient? Definitely. What is the term number? How many terms will we be having? Because the power is 10, we will be having n plus 1 number of terms, so that is 11 terms. So second last term is equal to the 10th term, because we will be having the total of 11 terms. The second last term will be the 10th term. This you have to realize, okay? Because they have not given the term number. They could have said the third last term or the last term. Then what do? What is the last term? It is the 11th term. What is the third last term? It is the 9th term. Here, let me write this properly. So it is the 10th term. And as soon as you know the term number, you know the value of R. What do you know? You know the value of R. So A is equal to, let us start with A. A is equal to x squared. B is equal to 2. N is equal to 10. And R is equal to, remember, the starting value of R is equal to 0. So the value of R in the 10th term will be equal to 10 minus 1, which is equal to 9. So the R value is equal to 9. Okay, fine. What was the general term? I'm writing it once more. NCR e to the power of n minus r and b to the power of r. Okay, so we'll be just substituting. It will be 10C9. NCR 10C9. E is what? X squared. To the power of n minus r, that is 10 minus 9. And there is this multiplication sign in between. B is equal to 2. 2 to the power of 9. 2 to the power of r, b to the power of r, so 2 to the power of 9. Fine. And 10C9, what will this be equal to? We have seen that n minus 1. R is in this case, since n value is equal to 10. So R value is 10 minus 1, that is n minus 1. And what will be the value of n minus 1? It will be equal to n. We have seen all these in our previous session. Right. So this will be, and in case you want, I can verify it. I can show you that indeed you have the 10C9 value to be equal to 10. C10. Okay. 10 and x square raised to the power of 10 minus 9 is 1. So it is, let me write x squared. Sorry. X squared to the power of 1 is x squared. And 2 to the power of 9. 2 to the power of 9, if you most probably, not most probably, it is guaranteed that you have learned computer. So what is 2 to the power of 9? It is 512. So this is 512, which is equal to 5120 x squared. And they have asked for the coefficient, not the entire term. Okay, if they had asked for the entire term, our answer would have been 5120 x squared. But they have asked for the coefficient. So the coefficient, oh my goodness, sorry. Coefficient of the second last term is equal to 5120. Okay. So this is how you get the coefficient. If they ask for the term, you get the entire term. And if they ask for the coefficient, it will be the number. And in case you have any other variable, we will be taking multiple variables in our coming sessions. In that case, you have to include the other variable also in the coefficient. You have to just exclude the x part. Okay. So students, let us stop over here for today. Thank you for staying with me for the whole session. I hope you have understood whatever I have explained. In case you have any difficulty, any question, please feel free to write to me. Bye.